These are the most frequently asked questions for Algebra 2 for section 5.4 day 1, starting with number 11. So in number 11, we have a little x minus 1 for our dividend, and then we have x cubed plus 3x squared minus x plus 2. X minus 1 is our divisor. X cubed plus 3x squared minus x plus 2 is our dividend. And what we want to do is always focus on matching that first term. So I have my little x minus 1, and I need it to be an x cubed. So I'm going to have to multiply by x squared. When I do that, I get the x cubed that I wanted, and I also get a negative x squared, because x squared times negative 1 is negative x squared. Then what we have to do is we have to change the signs and add. And I see that what I wanted to happen is happening here. X cubed plus that negative x cubed, or just thinking of it as subtraction, is going to be 0. So I'm going to put my little x squared, my factor up here that I used, I'm going to use that right above the x squared, because again, we just want to line this up nicely. And then I go ahead and figure out what I have. And x cubed minus x cubed is 0, and 3x squared plus an x squared will be 4x squared. And just like normal long division, we're going to bring down the next term. So down comes that negative x. Again, I start with my x minus 1, and I'm trying to figure out how I'm going to get rid of that 4x squared. Well, I'm going to need a 4x. So if I multiply that out, that will give me 4x squared minus 4x. Again, we have to change the signs and add. And what I wanted to happen is happening. The 4x squared minus 4x squared will be 0. So I'm going to put my little plus 4x up there because it was a positive 4x for my factor. And then I have a negative x plus 4x, and that will be 3x. And then I'm going to bring down that last term, which is the 2. So I'm back here again with my x minus 1, and now I need it to be a 3x. So I'm going to multiply it by 3, and that will give me 3x minus 3. We need to change the signs, and we need to add. Well, negative 3x and negative 3x are going to give you 0, so that means the 3 can go right up here. It earned its place. It did what it was supposed to do. And then we have a 2 plus 3, which is a 5. Now, there isn't any way for us to multiply x minus 1 by something and get it to be 5. It isn't going to happen. So what we have to do here is just leave that as our remainder. So this will be plus 5, since it's a positive 5, over x minus 1, our divisor there. So our answer, x squared plus 4x plus 3 plus 5 over x minus 1. Next one I had on the list here for you is number 15, with an x plus 3 for the divisor, and x squared minus 7x plus 10 is going to be our dividend. So what we do is we use our little x plus 3, and we say to ourselves, self, I need an x squared, so I'm going to have to multiply that by x. And that will give me x squared plus 3x. We change the signs, and we add. And we can put our little x in its place of honor up there because it did its job. X squared minus x squared is 0. Negative 7x minus 3x is a negative 10x. And then just like normal long division, we're going to bring down that next term, which is a plus 10. So I go back to my original x plus 3 divisor, and I think, well, how am I going to get that to be a negative 10x? Well, I'd have to multiply it by negative 10. And that will give me negative 10x minus 30 when I distribute that. And then what we have to do is change the signs and add. Well, my negative 10 can go up here because it did its job. Negative 10x plus 10x is 0. And then I have a remainder here of 40 because there's no way to multiply x plus 3 by something and get it to be 40. So this is going to be plus, because it's a positive 40 over x plus 3. I was over the divisor there. We don't use that R notation. Then, on the next page, it says, determine whether each binomial is a factor of x cubed plus 4x squared plus x minus 6. If it is a factor, we will not get a remainder. So what we want to do is our polynomial long division, and we want to see, do we get a remainder? If we do, it's not a factor. If we don't, then it is a factor. So I have my little x plus 1, and I need it to be x cubed. That means it's going to need an x squared out there, and that'll give me x cubed plus x squared. I change the signs and add, and it does its job, so I'm going to put my little x squared up there, and that will give me 3x squared. Now I bring down the next term and start over with my little x plus 1. Well, now it's going to need a 3x, so that it'll be a 3x squared. So 3x squared plus 3x. Change the signs and add. Well, my little 3x can go up here because it did its job. 3x squared minus 3x squared is 0. And then I have a negative 2x, and I bring down my last term. So now I'm back over to the left, looking at my x plus 1, trying to figure out how am I going to get that to be a negative 2x, and I would have to multiply that by negative 2. So that will give me negative 2x minus 2. So I change the signs and add, and it did do its job, so I'll put my little negative 2 up there. X's drop out, however, we have a remainder. So determine whether or not this is a factor? No, it's not. X plus 1 gave us a remainder. It did not work out perfect. So let's check and see what happens with x plus 3. All right, so got our little x plus 3, and it needs to be x cubed, so we're going to multiply by x squared. Change the signs and add. Well, x squared can go up here because it did its job. We'll get x squared. And then we're going to bring down the next term. And now we go back to our little x plus 3 to figure out how do we get that to be an x squared in the first position. We get that by multiplying by x. So x squared plus 3x. Change the signs and add, and that x is doing its job. I'm going to be able to drop out those x squareds, and I'll get a negative 2x, and I'll bring down the last term. Back to my x plus 3. I need it to be a negative 2x, so I'm going to multiply by a negative 2, and I get negative 2x minus 6. Change the signs and add, and it did its job, so we'll put our little negative 2 up there, and even better, no remainder. So, yes, in number 19, that is a factor. Worked out perfect, no remainder, things were good. Number 44, now we're talking. We've got 2x plus 1 dividing into 2x cubed plus 9x squared plus 14x plus 5. That has a little more meat on its bones there. All right, so just like before, we start with our 2x plus 1, and we try to figure out how do you get that to be 2x cubed. Well, you're going to need an x squared to make that happen. So you multiply that out, and you get 2x cubed plus x squared. You change the signs, and you add, and you realize that your little x squared did its job, so it gets up there, place of honor. And then we have 8x squared. You bring down the next term. Go back to our little 2x plus 1. And I'm going to need to multiply that by 4x to get my 8x squared. So that will be 8x squared plus 4x. Change the signs and add, and our little 4x can go up to its place of honor because it did its job. And 14x minus 4x will give us 10x. And then we're going to bring down that last term. So now we have our little 2x plus 1. And we want that to be a 10x, so we're going to multiply by 5. And that gives us 10x plus 5. And hopefully by now you can see, hey, that's a good thing. We're going to change the signs and add. And our little 5 did its job. And we just happen to get no remainder this time. So our answer is x squared plus 4x plus 5. Now I will take you through number 47. Number 47 has a little x cubed minus 1. That looks like trouble. And then we have x to the 4th plus 4x to the 3rd. And if you're worried that there's no squared term there, you can always put 0x squared for a placeholder. Some people get a little messed up when they see that something's missing. So now we've got our little x cubed minus 1 over here. And we're wondering, does that divide evenly into all this? And we'll find out soon enough. It needs to be an x to the 4th, which means I have to multiply by an x. And that will give me x to the 4th, but it also gives me minus x. Well, it doesn't make any sense to line that up here because those are not like terms. Pardon me, had to sneeze. So what we're going to do is we're going to line it up underneath the other x term. Change the signs and add. Well, it's doing its job. Let's put our little x where it needs to go in the place of honor. And my x to the 4ths are now gone, but look at this. Good news. That x term is gone back there now too. So I still have some stuff left. I have my 4x cubed left, and I have that little minus 4 hanging in the back yet. So I don't want to forget about those two. Now, we've got our little x cubed minus 1. And if I'm going to get that to be 4x cubed, I'm going to need to multiply it by 4. So that gives me 4x cubed. So we change the signs, and then we add. And again, this is fantastic. So we're going to put our little 4 in the place of honor up here. And this is also fantastic. And now everything has been used. So this one worked out perfect. So when we take x to the 4th plus 4x cubed minus x minus 4 and divide it by x cubed minus 1, we get x plus 4. Very nice little problem there.